7.5 Strategy for Integration. As we have seen, integration is more challenging than differentiation. In finding the derivative of a function, it is obvious which differentiation formula we should apply. But it may not be obvious which technique we should use to integrate a given function. Until now, individual techniques have been applied in each section. For instance, we usually used substitution in exercises 5.5, integration by parts in exercises 7.1, and partial fractions in exercises 7.4. But in this section, we present a collection of miscellaneous integrals in random order, and the main challenge is to recognize which technique or formula to use. No hard and fast rules can be given as to which method applies in a given situation, but we give some advice on strategy that you may find useful. A prerequisite for applying a strategy is a knowledge of the basic integration formulas. In the following table, we have collected the integrals from our previous list together with several additional formulas that we have learned in this chapter. The table of integration formulas. Constants of integration have been omitted. Number 1, the integral of x to the power n dx equals x to the power n plus 1 over n plus 1. Open, n not equal to -1, close. Number 2, the integral of 1 over x dx equals the natural log of the absolute value of x. Number 3, the integral of e to the power x dx equals e to the x. Number 4, b to the power x dx equals b to the power x over the natural log of b. Number 5, the integral of sine x dx equals negative cosine x. Number 6, the integral of cosine x dx equals sine x. Now omitting the numbers, the integral of secant squared x dx equals tangent x. The integral of cosecant squared x dx equals negative cotangent x. Redoing number 7, the integral of secant squared x dx equals tangent x. The integral number 8, I might as well continue to number them. The integral of cosecant squared x dx equals negative cotangent x. Number 9, the integral of secant x tangent x dx equals secant x. Number 10, the integral of cosecant x cotangent x dx equals negative cosecant x. Number 11, the integral of secant x dx equals the natural log of the absolute value of secant x plus tangent x. Number 12, the integral of cosecant x dx equals the natural log of the absolute value of cosecant x minus cotangent x. Number 13, the integral of tangent x dx equals the natural log of the absolute value of secant x. Number 14, the integral of cotangent x dx equals the natural log of the absolute value of sine x. Number 15, The integral of the hyperbolic sine x dx equals the hyperbolic cosine x. Number 16, the integral of hyperbolic cosine x dx equals the hyperbolic sine x dx. The integral of dx over x squared plus a squared equals 1 over a. The inverse tangent of open x over a close. Number 18, the integral of dx over the square root of a squared minus x squared equals the inverse sine of x over a. And a is greater than 0. Number 19, the integral of dx over x squared minus a squared equals 1 over 2a, the natural log of the absolute value of x minus a over x plus a. Number 20, the integral of dx over the square root of x squared plus or minus a squared equals the natural log of the absolute value of x plus the square root of x squared plus or minus a squared.